Greetings everyone, welcome back to the bench. Today on the bench I have a stereo TPA3116 board we're going to take a look at. Assisting me on the bench in the meatloaf posture, all extremities tucked in, we have the Snickers. I've reviewed 3 or 4 other TPA3116 boards here on the channel, and out of all the Class D boards that I have reviewed, I like the TPA3116 based boards the best. And of those boards, some were better than others. I always find faults with these things. And just looking at this one, it looks like it could be pretty good. So what do we have here? On this end we have a stereo input jack, a stereo input socket, a volume control with hard power, as opposed to like a standby type mode, because the power comes through this trace up to the switch. So yeah, when you turn this off, you cut the power instead of going into standby or something like that. Let's see here. We have 4 1000 microfarad 35 volt caps, and that's plenty. I mean, it's already DC, but it's good to have a little bit of reservoir on the supply lines here. The heat sink here, that's a little concerning. It's not that big. Even though it is Class D, it's still got to dissipate some heat. Nice thing is you can unscrew it, and somebody wrote TPA3116. This is one of the boards, that guy who sent a bunch of electronics to me, sent it in that package, so I figured, well, looks pretty neat. I think I'll review it. But anyhow, you can remove the heat sink if you want and add a larger one maybe. Just don't torque this down too much. You don't want to flex the board. On the output side here we have decent size filter chokes. These are the filter caps. And the better quality connectors, usually they have those blue ones that are kind of crappy, but these are okay. Another thing I see here, this diode here, it's on the input, or I should say the power input here. It's a Schottky diode rated 5 amps. And if you watch my channel, I reviewed that one board that had 2 1N 4001 equivalent surface mount diodes in parallel, and it's only 2 amps. And those things get really hot when you're running the amp hard. But being Schottky, it'll have a lower forward voltage drop, plus being 5 amps, it can actually handle the current. I'm still not saying you can run this thing at 24 volts 2 ohms, but we will take a look at the frequency response to see if these coils are adequate. You know, with one of the nicer amps, when I tested its frequency response, it just kind of dropped off pretty quickly at higher frequencies, because they were using coils that were really meant for 8 ohms. And you know, this setup, you know, you can run it 4 ohms, even 2 ohms at lower voltages. See, the neat thing about this, you have 2 TPA3116 chips. Those chips alone are stereo, so what they're doing, they're paralleling the channels together for each chip, you know, for each channel here, for the left and right channels. So that means the amplifiers inside each chip only have to supply half the power, I should say half the current. So that's another big thing I like. So there's just a lot of nice things I'm seeing with this. You know, just glancing over at the layout, looks pretty good. But let's hook this thing up and see if it is really a decent amplifier. Okay, we're on the supply. I paralleled both supply channels together, so I have more current for driving this thing. We tested at lower impedances at 24 volts. And here it is. So our LED color is going to be blue. It's not a blinding blue, but it's blue. And just plug in the music player, and we'll give you a music sample. Okay, sounds very good. Might have overdriven the camera mic here at first because it was up kind of loud. But let's see here. Very little noise at idle. That's good. No low-level distortion like I've seen in a couple amps. None of the TPA3116 ones though, but if you've been following my channel, I had a problem with, I don't remember the amp number, but a couple of them at low volumes, the sound was all crunchy and distorted. So all is well with this one. I almost forgot to mention that this amplifier has plenty of gain for headphone type output devices like phones and music players. Some of these amplifiers, the gain is low, and even with the volume wide open, you're not driving the amp to clipping, so you're not getting its full potential. You're not getting its full output power. But this amp, at least with the 12-volt supply, I can drive it to clipping when I crank it all the way up, using this music player, which only has about 500 millivolts RMS output, and that's below line level spec. So that's another plus. It works good with headphone output type devices. Anyway, I now have the amplifier connected to my non-inductive 4-ohm loads, both channels. Have the scope connected across one load. And why I'm thinking about it, I have some people ask me every now and then why, when I connect the scope's ground to one of the outputs, this is a bridged output, so both outputs are floating above ground. They're not ground referenced. So how do I not blow the channel up? Well, you have to have a loop, a return path for that to happen. Well, of course, my signal source is not grounded because it's a battery operated music player. My power supply is floating. I'm not connected to ground. So there's no return path to short the output when I connect the scope's ground. So that is why I don't blow the amp up when I connect the scope's ground to its bridged output. Okay, so what I'll do is take one power measurement on camera here, and I'll do a bunch of others and report them at the end of the video, just as usual. Now, somebody is asking me why don't I use the FFT mode and watch the harmonics start to peak up when it begins to clip. Well, that is the right way of doing it, but it's just easier for me, plus I'm kind of lazy, just to look at the clipping on the sine wave here. So I'll just dial the clipping out, and we're putting out the wrong voltage setting here. I had my probes in 10x. Let's get that set. There you go. 7.6 volts. Of course, that's an RMS measurement. 7.6 squared divided by 4. And that's pretty much what I would expect with any bridged amplifier running at 12 volts. Okay, we're taking a look at distortion. I'm going to test it at 4 ohms. Give the amplifier a bit of a challenge. This is the 1 kilohertz fundamental, 4.5 kilohertz reference signal that I put in. It's at 1% of this, That way I can compare that with any nodes that I see. And I don't see any nodes. I mean, these jump up now and then, but I think it's just noise because they're not consistent. So the amplifier is really clean. Okay, so this is the distortion at 10K. We're seeing some small nodes there, nothing to be concerned with. I don't have a reference signal in the 10K test signal. This is the 20 Hertz distortion. I guess I'm at the limits of the scope. I can't get this to move all the way over, but it doesn't matter because I'm not really seeing anything to worry about. Okay, let's take a look at frequency response. This will be the 10 to 100 Hertz sweep. We're starting a little bit low. Right there is 20, about 2/3 there, so it's looking like our low end is a bit weak. So we're not quite up to this graticule. That's 0 dB level. Okay, we're just about at 100 and we're at full level now. So yeah, at lower frequencies it's a little bit weak. Probably the input capacitors are too small that they used. Okay, this is the 20 to 20 kilohertz sweep. Okay, so we're around 9 kilohertz and we're rolling off pretty quick with 4 ohm loads. That's the disappointing thing. They choose the wrong coil values and our response starts to roll off. Okay, we're almost at 20 hertz and we dropped 6 dB. So frequency response is pretty terrible. And again, I think that's the value of the coils they use. They might have chosen the values to use with 8 ohm loads. So that's why we're seeing that. Just for grins and giggles here, let's run this at 8 ohms. I want to see how it performs with 8 ohm loads. So we're at 10 and it's still holding out. It's dropped ever so slightly. But it's pretty obvious that I always turn the wrong direction. But it's pretty obvious that this was set up for 8 ohm loads. Okay, we're almost at 20. And see how it stayed up higher? It didn't drop down nearly as far as with the 4 ohm load. Here are the power output measurements I got from the amplifier. So with 8 ohm loads, I got these values. I'm not going to read everything off. But at 12 volts, 7.3, at 18, almost 17 watts. 24 volts, we hit just about 29 watts. And the power supply current at 24 volts with the 8 ohm loads, of course this is both channels driven, was 3 amps. So with 4 ohm loads, 12 volts, we got 13.7. It was 14.4, but I forgot to set the scope. I have to put at least 8 wave cycles or 8 cycles on this screen to get the correct voltage measurement. So that drops the measurement just a bit. So it's actually 13.7 at 24 volts. We hit an amazing 55.4 watts. And we're drawing 5.4 amps at that level. I measured 2 ohm loads. I really don't recommend running this thing at 2 ohm loads more than 12 volt supply. These are the power measurements. I noticed at these levels here at 14 and 16 volts with the 2 ohm load, the sine wave was getting distorted. It was starting to look triangular. So the amp is just not set up to use with 2 ohm loads. Though if you want to keep the supply voltage up 12 volts or less, you could. I don't know why you'd want to, but Just so you know, even though they say you can, do not do it. The quiescent draw was around 50 milliamps, which is very good. The minimum supply voltage, it ran down to 4.5 volts, and then it just shut down. So it's very versatile if you want to run it at 6 volts. You won't get a lot of output power. You might get 3 watts into 4 ohm loads, but it makes it versatile if you want to use a smaller battery. Well, there you have it, another TPA3116 amplifier board test. This is the best one I've tested so far. Like I say, I like a lot of things about it. However, they still manage to botch up the frequency response. It just rolls off too early with 4 ohm loads. Okay, if you want to use 8. Now, if you want to fix that issue at the low end, in the bass region, you would have to monkey with the input coupling capacitors, probably one of those little surface mount things down there, or well, it could be those, but I don't have surface mount parts on hand to monkey around with. But I guess we'll leave it at that. Thanks for watching.